Nestled within the Triangulum Galaxy, 2.73 million light-years away from Earth, there is a stunning star-forming region called NGC 604, and it's just been imaged by JWST. In fact, it looks so nice they imaged it twice. In this video, we'll talk about what we're actually looking at in this gorgeous image. Plus at the end, I can also show you an image where JWST saw the same exploding star twice, thanks to the power of gravitational lensing. The Triangulum Galaxy is a member of the local group of galaxies, meaning that it's one of the closest galaxies to us, despite still being over 26 sextillion kilometers away. That's a number that looks like this and is huge. It is a small galaxy, thought to be a satellite of the much more famous Andromeda galaxy, and it's named after the Triangulum constellation in which it lives. And it's also known as M33, the 33rd object in Messier's famous catalogue. Within this galaxy is the star-forming region we're interested in today, NGC 604, a violent place full of dust and gas that has become a stellar nursery. The birth of stars is a hot, violent, and explosive process where dust and gas is crushed to temperatures and pressures so high that nuclear fusion ignites the ball and it bursts into life as a newborn star. JWST has now peered into this region using two of its detectors, the near-infrared camera NIRCam and the mid-infrared instrument MIRI. In these beautiful images, we can see cavernous bubbles and long, stretched-out filaments of gas, etching the detailed story of the birth of a star. Amongst the dusty dunes are more than 200 of the hottest and most massive kinds of stars, each one in the early stages of its stellar life. These are known as B-type stars and O-type stars, and it's rare to find these types of stars so densely packed together in the nearby universe. In fact, we actually don't know of any similar regions anywhere in our own Milky Way galaxy. So it's cool to see something in this galaxy that we have nothing similar to nearby, and nothing to compare it to in our own galaxy. And this gives us a unique chance to study these big, hot stars. In the near-infrared image, I think the thing that strikes me first are the stunning colors we have on offer. In this annotated version of the image, you can see the exact colors that were assigned to each wavelength of near-infrared light to make this image. So this tells us that longer, lower energy wavelengths of light were assigned redder colors, and shorter, more high energy light was given green or blue colors. The most noticeable features include the long tendrils and clumps of bright red emission. These seem to be extending out from vast cavities, which look like huge bubbles throughout the image. It was actually stellar winds, radiation thrown off by the brightest and hottest young stars that formed these cavities around them. And then ultraviolet light ionizes the surrounding gas, heating it up and causing it to glow with ghostly whites and blues in this image. If we move out from here, we can see the distinctive and beautiful dark red glow that dominates a lot of the image. This is cooler gas, largely consisting of something called molecular hydrogen, and this cooler region is perfect for star formation, meaning new stars will eventually emerge from these red streaks of color. The surrounding orange areas also contain lots of carbon-based molecules known as polycyclic aromatic hydrocarbons, and these can be important ingredients for the formation of planets as well as stars. So in the far future, this whole region could well be home to future planets, and even life staring back at us. No promises though, that's just me dreaming. You might have also noticed this bright white spiky guy up here too. That's a nearby star in our own galaxy just getting in the way of this image. Photobombing because it's in our line of sight into this region. The star looks quite cool, but to lots of us, these foreground stars are the least interesting things in these images, and they do appear in most of JWST's images. If you want to know why it's spiky instead of round or star-shaped, then I have a whole video explaining that, which you can check out right here or in the description below. Just make sure you finish this video first and then go back to the other one. If we now fade to the mid-infrared image, things look quite a bit different, and we get a new perspective on this diverse and dynamic region. For instance, there are many fewer stars visible in this image. This is because the hot stars in this region emit a lot less light in these longer wavelengths. Some of the stars that we can see here are red supergiants, and these stars are generally quite cool in temperature, but are very, very large, at hundreds of times the diameter of our sun. We can also see larger clouds of cool dust glowing in blues and pinks, while the blue tendrils here again show the presence of those delicious polycyclic aromatic hydrocarbons. NGC 604 has been imaged before by other telescopes such as Hubble, so let's do a quick comparison fade here. Other than the obvious color and detail differences, we can get a sense of how good JWST's resolution is. In these images, there are two bright young stars carving out holes in the dust above the central nebula, near the top of the image. In visible imaging from Hubble, these bright objects seemed separate and unconnected, but with JWST, we can see they're actually connected through the diffuse red gas. We're able to learn about the dynamics and the evolution at play here, and it is fascinating. It also might look really small, but the region we're looking at is about 1,300 light years across. That's more than 7 quadrillion miles. Right, I also promised you a look at a supernova experiencing some intense gravitational lensing. In November 2023, JWST took this awesome image of a massive cluster of galaxies called MAX J0138. 0.0-2155. And here we can see some awesome things. Almost as awesome as me saying that number right first time. Firstly, the warped shape of these galaxies is due to an effect called gravitational lensing. I'd like to keep this video as short as I can, so I won't go into the details here, but I have gone into it a whole lot more in other videos about JWST images that also show gravitational lensing. So again, I'll link one up here and a couple in the description below in case you'd like to hear more about it. In short, the TLDW is that galaxies behind the massive cluster can have their light bent by the gravity of that cluster, causing us to see them with their shapes warped, their light brightened, and sometimes repeat images of the same objects are visible too. Now, it's basically impossible to accurately predict when a supernova is going to explode, so spotting them is almost always done by chance. In 2019, astronomers finally got lucky and saw a supernova in this warped galaxy here, which has the catchy name MRG MO138. Now, back then, it was before JWST launched, but in this Hubble image, they saw bright spots, and they were able to confirm that this light was from the same supernova. They nicknamed it Supernova Requiem, and it had a few cool features. One being that it was 10 billion light years away, so very distant. And the other was that they could actually predict a third image of the same supernova. They think it's going to appear here in 2035. You see, supernovae are only visible for days or weeks at most, and when they're lensed like this, their light takes different paths through the cluster to reach us and our telescopes. These paths often have different lengths, so it takes a different amount of time to travel those paths, and so there can be a time delay between different images of the supernova reaching us. These time delays can then teach us an awful lot about the cluster itself, so they are amazing to find, albeit rare and pretty hard to discover. Once we've learned about the cluster in detail, we can work out other possible paths that the light will take, and hence predict future supernovae appearing in the sky in the future, from light that took a longer path than these ones that we've already seen. What's then amazing is that in this new JWST image, a second lens supernovae has been seen in the same warped galaxy. The bright spots here and here are both the same second supernovae, now nicknamed Supernova Echo. Again, a third image is expected sometime around 2035, assuming our models of the universe and this cluster are correct. So stay tuned for a video on that in 11 years when we finally see it. For now though, I want to hear from you in the comments below. Do you like these images? Do you have any questions about them? And what are you hoping to see JWST image in the next few weeks and months? Let me know down there. Thanks for watching, and please consider subscribing if you're new. I will do a personal fist bump just for you if you do. Until next time, stay safe team, and I'll see you soon. Bye!